Good morning. This is Mr. Burns, science teacher with CPDLF. And today we're going to do our first chemistry launch. We've missed a week on this because I had technical problems and couldn't do a launch until today. So thank you for attending this morning. As always, if you have any problems, well, I hope everything's going well in the course. If you have any problems or needs with anything, be sure to contact me. I want you to be successful. I want you to do well. So let's keep good communication as the course goes on. Chemistry can be a little bit difficult, but the more you do it, the more used to it you get, and the more you understand. So let's do it together and work hard for the rest of the year. Let's get a good grade. I normally go over difficult sections from last week. That's the first thing I'd like to do. The hardest one that you might have done last week, I would think, would be metric conversions. Since our country uses the English system of measurement, people are not used to the metric system. And it's really not that hard. In fact, once you learn it, it's not hard at all. You need to remember that there's a base unit in the metric system. There's always a base unit like the meter or the kilogram or the liter. Those are base units. And everything that is more than that is 10 times more than that. Like the first step up from there, if we were talking about meters, would be a kilometer. Or actually, that's not true. That'd be a decimeter, and a decimeter would be 10 times a kilometer, 10 times a meter. A kilometer then would be 10 times a decimeter. And so each step is 10 times as great as the one that comes before it. Now the other way, if I was talking meters again, my first, everybody likes to jump to centimeters, and that is 1/100th of a meter. But a decimeter, a decameter actually is before that, is 1/10 of a meter. So you have decameters, you have centimeters, you have millimeters, and it goes like that. Each one is 1/10 less than the one that came before it. So you need to remember that and just get used to doing those conversions. If you need help with that, please let me know, and I'll work through it with you. For this week, you're going to do lesson 2.8, using significant figures to show the reliability of data. There are certain rules for significant figures that need to be followed. And the rules for multiplication and division are different than addition and subtraction. And you might not think that sig figs are very important, but they actually are. In science, if you don't use correct sig figs, your answer gets can get more and more wrong. Okay, every step of the way, it just can get more and more wrong. So they're extremely important when it comes to accuracy. That's lesson 2.8. Then you're going to use scientific notation with significant figures, 2.9. Quiz 2, precision, significant figures, and scientific notation, 2.10. Measuring volume in the chemistry laboratory, that's 2.11. The project this time is practice in measuring metric volumes, that's 2.12. And lastly, measuring mass in the chemistry laboratory, 2.13. So again, work through them, do the best you can, take it slow, one step at a time. Very often, if you just reread the directions and just take it slow, you'll understand it. The more you work with all of those things, the easier it becomes. If you need help, please let me know, and I'll be glad to get back with you. So have a great week, and I'm sure we'll be talking. Bye now.